Good morning. I am Prabhu R. Pevin Marad, Assistant Professor, Department of Computer Science and Engineering, BIDCET, Vijapur. So in this lecture, I am going to discuss about the user-defined functions and recursion concept. So the contents outline is, so why do we need the functions? Definition of the function, and what are the components required to implement a functions and its description, and some of the program concepts which are implemented by using the function concept. So let us ask a question ourselves: why do we need a functions in C? So the functions are used because of the following reasons. So to improve the readability of the code. So whichever the programs which are implemented by using functions, those programs can be understandable very easily, because such programs are divided into modules, and each module is implemented by using function. So whenever that particular module task is required, only that time it is called and it is executed. So the concept of function improves the reusability of the code. A same code can be used again and again instead of rewriting the same. So it is also used to debug the code easier. So errors can be found easily and the program can be traced easily if the program has been implemented by using the concept of function. So it also reduces the size of the code. So duplicate set of the statements are replaced by using function calls. So instead of writing same code again and again or duplicating the set of the instructions or the statements, so we can use a function call. So here only one time we will construct the body of the function, and we can call any number of the times. So let us first understand what is meant by the C functions. A function is a block of the statement that performs specific task. So it's a block of the code which performs particular task. So there are two ways to implement a program in C language. So the first way is, so we can use the same set of the statements every time. Suppose if you want to perform the task, so instead of using function, we can also create a program. So there a same set of the functions will be written every time to perform a particular task. So another way is, we can use the function, or we can create a function to perform the task, and just we will use a concept of function call to perform or to execute those particular tasks here. So let us consider an example here. So I want to find the square of a number. So here this program has been implemented without using the concept of the function. So here a variable has been declared to store the square of a number. So directly I am executing a statement which performs the square of the number by using the number 4. So this particular instruction will find a square of the number, and the result will be stored in a num variable, and we are displaying the content of num. So the num will be holding what here? The square of 4. Suppose if I want to find the square of another number, let us consider 5. So again what I am doing, I am repeating a statement here. This particular statement I am repeating here. Again I am writing a printf statement to display the result. So similarly, suppose if I want to find the square of a 6, square of a 7, or square of a 8. So every time if you want to find the square of another number, you have to repeat these two statements to perform the square of the number operation and to display the result. So here what happening, these two statements are repeating again and again. So the code size is going to increase here. Same set of the statements are duplicated here. So we can reduce this particular duplication by using what here, the concept of the function. So here what we are doing, we have implemented a separate set of the instructions. So these set of the instructions are separated from the main program. So this is main program and this is a function body. So this particular function body will perform the square of a number and the result is returned to the main program. See, we shall discuss how these functions are implemented in the next section, but let us see how the execution of the code will be done here. So as usual, we have taken a number which stores the result of square. So this is called as function call. So we are passing value 4 and we are calling this particular function. So whenever this statement is executed, the control will hold this 4 value as a parameter of the function and the control will come to this function body. So all these statements will be executed. So here the 4 is stored in the variable num. So here, the variable n1. So what we are doing, we are multiplying the content of n1 with what here, n1. Nothing but we are performing the square of a number. The result is stored in x, and after execution of this statement, we are returning a result back to the function here. So here num will be holding what here, the square of the number 4. So after this we can write a printf statement to display the value. Again, suppose if I want to find the square of the number 5, so again we are writing a statement, we are calling a function by passing the value as a what here, 5. So again what happens, the control will jump to here. Now the n1 value will be what here, 5. Again the square of the number will be computed, it will be written back to this particular line once after the execution is completed. So now num will be holding what here, the square of the 5 result, and we are displaying here. Suppose if I want to find the square of a 6, just we call what here, the function. That function will perform the operation and the result will be written back, and that result we are going to display here. So one thing we can observe is, we are implementing the function, nothing but what task has to be performed only once, and we are executing many times just by calling that particular function here. So this is what the advantage of the function here. So here we are reducing the code which is repeated again and again in a previous program, and even you can see the debugging is also what here, easy. Suppose if we are having a program with more than one functions, so there we can find the error actually in which module it is going to appear. So only that particular module is traced. So this is the advantage of using a function. So let us see how the function is implemented, and what are the different categories of the function. So let us see the different types of the functions. A function is classified into two types. So one is what here, built-in function, and second one is user-defined functions. So the built-in functions designed and developed by the C developer, so which are already available in a C library. So we have already used scanf function, printf function. So the purpose of using scanf function is to read a data from the keyboard. Printf will display the data on the screen, and to find a power of a number, then we use POW function. To find a square root of the number, we will use sqrt function. Suppose if you want to allocate a memory dynamically, we will use malloc function, and already we have discussed regarding string length, to find length of the string, number of the characters present in a string. See, all these functions are already implemented by the C developers and which are stored in a C library. So suppose if I want to find the square root of a number, directly we will use it. So we are not bothered about how these functions are executed. Just we are calling these functions by passing some parameter. So let us take an example. Suppose if I want to find a square root of a number, so what I do, we can call n equal to sqrt. So within a bracket, suppose if I pass say 4, so this function will be executed from the library, C library, and it will return a result as a 2 in n here. So after executing this particular instruction, the 2 will be present in n variable. Suppose if I want to know what is the length of the string, say CSC. So what I can do, I can directly use strlen within a bracket, say in double quote CSE, right. Say if I say this is equal to n, then n will be having what here, the number of the character present in this particular string. So how many number of the characters present in this particular function, this particular string is calculated by this particular function here. See, already these functions are built and developed and which are stored in a C library. So such a functions are called as what here, built-in functions. And another type of the function we have is what, user-defined functions. So these functions are written by the programmers according to their requirement. So even we can write our own function to perform a specific task. So such functions are called as what here, user-defined functions. Say for example, if I write a function to find a factorial of a given number, let us say that function name I take it as what here, fact. Then this is what here, my user-defined function. Suppose if I take, if I want to find a sum of two numbers, and if I give the name of that function as what here, sum, then it is user-defined function. So the library function, built-in functions are called as what here, library function. Those are predefined, so already which are present in a library. So declaration inside header files, so they are present in header files. So body inside, so its body is present in DLL files, say printf function, scanf function. But user-defined functions are used to which are created by the user, which are used to reduce the complexity, reusability of the code. So creating a function or using the function concept is modular programming approach. So such as sum function, fact function, right. So one question which arises for every developer, how to design and develop a user-defined functions. So how can I create my own function to find addition of two number? How can I create my own function for multiplication of two number? So similarly, how can I create my own function to read a data of 50 students and display it on the screen? So the solution is, so in order to design and develop user-defined functions, the programmer need to establish and use the following three elements of a user-defined functions. So suppose if you want to create your own function, then you have to use these three elements to construct the function of your own. So let us see what is meant by this function declaration or prototype, and what is this function call and function definition. So the function declaration or prototype, so the function must be declared in a global declaration. So this is declared in a global part, right. So it provides three details of a function to the compiler. So before you construct your own function, you have to intimate the compiler that I am using so and so function, means I am using this particular name of the function, and it is taking these number of the parameters, and this particular function will return so and so value. So such a information is provided for the compiler before we implement our own function. So that part is called as function declaration or prototype. So the syntax for function declaration or prototype is the name of the function and the return type. So first you have to write the return type, the name of the function, and the argument list. So the return type indicates what type of the value your function is returning. So what type of the value means the return type may be what here: integer, float, character, double, etc. So the function name is nothing but what here: any valid identifier name. For example, see, I want to implement the function say add numbers to perform addition of two numbers, and after performing the addition, so this particular function will return what here: integer value. This is a meaning. And the argument list is nothing but what here: the number of the parameters your function is going to take. See, in case of addition of two number, how many parameters are required here? Two parameters. So that's why we are passing two parameters. We are declaring this function, we are mentioning this prototype by using what here: two parameters. Suppose if you want to find the addition of three numbers with the same function name, so how do we declare it? So add numbers, and after addition it will return an integer value, and instead of two parameters we will declare one more parameter, that is int say c. So after that bracket complete. So after b, int c, bracket complete here. So this function prototype has to appear in, has to declare above the main function, right? So let us consider one more example. I want to implement my own function by name multiply to perform the multiplication of two numbers. So how I will declare a prototype? That is return type. After multiplication it will return integer type of the data, and this is the name of my function, and how many parameters this function is accepting? Two parameters, means I am finding the multiplication of two numbers. Suppose if you are finding the multiplication of four numbers, you have to pass how many parameters here? Four parameters. So this is about what here? The function declaration or prototype. So in advance, intimating to the compiler that this is my function. So this is the name of my function I am going to implement in a program, and after performing some operation it will return so and so value, and it will take so many parameters. So this is called as function prototype. So now let us see what is meant by function call. So once after declaring the function prototype, so the function call is used to call the specific function body from the main function. So suppose if you want to execute the particular statements of the function, so that particular function you have to call. So whenever you call the function, the control will jump to the function body. So the syntax is what here? The name of the function and actual parameters. So let us consider an example here. So I want to develop a function, the name is what here? Add numbers, to perform the addition of two numbers. So this part is called as what here? This part is a function prototype, and within a main what I do, I will call a function to perform that particular operation. So by passing what here, n1 and n2 value, and after performing the operation the result has to be stored in this particular variable, right? So this is called as what here, function call. And next, function definition. So the function definition is nothing but what here, sub program which can be written before or after the main. So it is also contains a group of the statement to perform a specific task. So actually what has to be done, what operation has to be done, or what task has to be done, so that information will be present in function definition. So the function definition will be having set of statements to perform a particular task. So the syntax is, you have to first mention the return type and the name of the function and the argument list. So flower bracket open, so you have to write down list of the instructions which performs the actual operation, and after that you have to close the flower bracket. So this syntax you have to follow. So the name of the function has to match with the prototype name. The return type also has to match with what here, the prototype return type. The argument list has to match with what here, the number of the arguments which you have specified in the prototype. So let us see an example. Let us implement the whole program by using the function. So as I said already, we want to write a program to perform addition of two numbers. So assume this is my name of the function. So this part is called as what here, the function prototype. So the name is what here, add number. How many parameters it is taking? 2 parameters. After performing the addition, it will return what here, integer type of the value. So this is declared before main. So once when we enter into the main, so we will call this particular function by passing these two values. So whenever this function is called, the control will jump to the name of the function. So this first thing which is going to happen. So instead of executing this printf statement, in between only, whenever this call encounters, so it will jump to the function body. So first it will check the name of function is same as this call, yes, right? And how many parameters we are passing here? 2 parameters. So how many parameters this body is taking? 2 parameters. So match is found, complete match is found. So what happens? The A is added with what here, the B, and the result will be stored in this particular variable, and the result is returned back. So means what happens? The content of result is what here, the result of executing this particular function. So that is assigned to what here, sum, and the result we are, and the content of sum we are displaying here. So what happening here, actually this function body is separated from the function body is separated from the main function here. Okay, so again suppose if I call one more statement, one more call, say for example here if I mention say sum equal to say add numbers, so within a bracket, say if I write 4 comma 6, so then what will happen? Again the control will jump here. A will be stored with what here, 4, B will be stored with what here, 6. So these two values will be added, the result will be stored in, so the control will go back once after complete execution of these statements, the result will be stored in sum. So the sum will be having what here, the value 10, right? So what we are doing, what operation we want to perform now, those operations are separated from the main program, and only one time we are implementing the body of the function. So you can call this particular body of the function 1000 times without repeating these set of the instructions for 1000 times here. So only you have to insert the call statement, right? So this is the advantage of the function. So I repeat here, so to implement a function you have to first take care of the function declaration or prototype. So this indicates, this gives the brief information about your function to the compiler. So once after function declaration is over, so you have to call the function by using what here, following this particular syntax. So the call will change the control of program execution from main program to the function body. So once after the calling is done, so you have to prepare your function body by following this particular syntax. So keep in mind, the name of the function has to match with the call, the call statement, the function name what you have usually in call statement. Also it has to match with what here, the function name what you have usually in prototype, and the return type should also match with what here, prototype statement, return type, and list of the argument what you have specified in prototype, that has to match with what here, the function arguments, function definition arguments list. So let us see a few example here. See, assume I want to write a function, write a program using function to find a square and cube of a number. See, what we are doing, we are declaring two prototypes. So this particular prototype is for square of a number. So square of a number, SQUARE, square of a number, and this is for cube of a number. So these two are called as what here, prototype. So next we have declared a main function. So here we have taken variable n. So ans answer 1 will be holding what here, the square result, answer 2 will be holding what here, the cube result. So first we will ask the user to enter the number. So whatever the number which is entered by the user, that is stored in variable n. So next what we are doing, we are calling a function. So we are calling function square by passing what here, the n, right? See, the name of this function is the same as what here, the prototype function name. So how many parameter it is taking? Only one int we have declared. It means this particular function will take only one parameter, that is of type what here, int. And once after calculating the square of a number, the result it will return is of type what here, integer. So whenever this statement encounters during the execution, the control will jump to the body of the function. See here it is mentioned, it will jump here. So n value is stored here. So let us say I have given a value n as a what here, say 4. So the 4 is stored in x. So next what we are doing, 4 into 4, that is 16 is returned. We are returning value 16. So when it is returned, the control will go back. The result of this function execution is what here, 16, that is stored in ans1. So ans1 is holding how much here, 16. So after that what we are doing, we are calling another function. The name of this function is what here, cube, by passing the value n here. So the control will jump here. So say assume I have given a value n as a what here, 4. So the cube will be computed, the result will be returned back to this particular statement. So ans2 will be having what here, so that is 16. 4 4 is how much it is having? 16 fours are 20, sorry, yes, the cube result will be present, that is 4 into 4 into 4, that is 64 will be present in, say, answer 2. So that result is, so after that what we do, we display the content of ANS1 and ANS2 here. So even without using function also we can perform the same operation, but here we have separated two modules here. So one module which performs the completely the square operation, and another module which performs what here, the cube operation. So these operations are separated from the code here, right? And even we can call the square function say 100 times without repeating these set of the instructions 100 times. Only one time we have implemented this body, but we are calling 100 times, right? See, if you don't use the concept of the function, then you need to repeat this particular instruction 100 times, right? Let us see one more program. See, assume I want to find a factorial of a given number. So already this program we have implemented without using function. So let us implement this concept using function here. So so I have declared the prototype. So the prototype will be having what here, the return type. So the return type of this factorial function is what here, long int, and how many parameter it will take, one parameter. Say I want to find factorial of 4, say fact of say 4, right? Say I want to find fact of say 7, like this. Okay, see, whenever I say I want to find fact of 7, the result will be returned. So the main program, so we are taking a value variable n to hold the number for which you want to find a factorial, and ANS will be holding what here, the result of the factorial number. So first we will ask the user to enter the number. The user will enter the number, say for example 4. The 4 will be stored in n. So what we are doing, we are calling a function fact of n here. So whenever this function is called, so what is the value of n? N is 4. So this function will pass the control to its body. So the content of n is copied to x. So x becomes how much here? 4. So what we do, so this is a temporary variable which holds a factorial of a given number. So we will start from 1 here. So I value is what here? 1. So 1 is less than x. Yes, the condition is true, it will enter into the loop. So product of PRO into I. So that is 1 into 1. Again the control will go back to this for loop. I value is what here? 2. So 2 is less than say 4. Yes, the condition is true. So prod into I means what here? Previous value of I is what here? 1. So it becomes how much here? 1 into 2. So next, in next iteration it will be what here? 3. In next iteration it will be what here? 4, right? So like this the factorial of 4 will be calculated and the result will be stored in probe, and after finding a result, the result is returned by using return statement. So the control will go back, so the result of this function is what here? 1 into 2 into 3 into 4, that is 24. So 24 is stored in ANS. So we are displaying the content of ANS. So what happened here? So this is main program, right? So the main program is separate separated from the function body here. So what we are doing, we have called this particular function from the main program. So what happened here, it was executing sequentially. So whenever this call appeared, the control is jumped to body, it has performed the operation, and once operation is completed, it went back to the point where it was called. So this is what here the function. Say for example, if I want to find a factorial of say 7, so then what I can do here, we can call one more statement here after this, that is fact of 7. See, any number of times you can call. So the same body will be executed whenever it gets a call. Thank you. In next lecture we shall discuss what are actual and formal parameters in a function, the category of the functions based on number of the arguments and return value, and we'll see the parameter passing mechanisms, and will implement some of the programs using the above concepts in C programming. Thank you.